Hello everyone and welcome to this webinar exploring artificial intelligence's uses in retail, specifically for inventory and stock optimization when combined with RFID. We recently attended the AI in Retail conference here in London, and we heard a lot about how retailers are using the tech for chatbots and virtual assistants, but not so much about using it for optimization and business intelligence. So that's what we're going to talk about today. If anyone has any questions throughout the webinar or at the end, please put them in the chat at the bottom and we will get to those. So without further ado, I'd love to introduce our senior data scientist, Simon Walk, and he will take you through the presentation.
All right, so thank you, Joel, for the introduction. So today we're going to talk about AI for inventory and stock optimization, and actually what we're doing here at Detego to ensure that the right products are in the right place at the right time. So first of all, I want to give you a brief introduction to Detego. So we provide RFID-based software solutions for retailers, and in particular fashion retailers. And why are we doing this? So what are the biggest benefits of RFID? And this is particularly in the context of AI and machine learning. So the most important point is that RFID provides us with real-time data. And it's not just real-time data, it's also a lot of real-time data, which is something that every data scientist needs to actually come up with good models and good data, good KPIs for fashion retailers to use. Also, RFID allows us to have a better grasp on inventory visibility, which I'll talk a little bit about in the upcoming slides. Also, it allows us to have a better understanding of the supply chain traceability, and it enables us to have an increased product availability. So all of these things I'll show in the next few slides. And so why should you trust anything that we're saying? Because we have customers all around the world who actually use our software, and they kind of like trust in us to provide them with the correct KPIs. So to be able to really understand how the whole AI in retail and stock optimization works, we have to get an understanding of how the whole process in general works with RFID. So to that end, we first have to have a little look on an actual supply chain. So this is a very abstract view of how the supply chain for a fashion retailer looks like. So we start in a factory where the factory workers do something that we call source tagging. And what that actually means is that every single item in the factory is assigned with an RFID tag. So here, those are the small blue and red squares that are put on every single item. They are then packed and sent to the warehouse. But before this process is actually starting, so before the carton actually leaves the factory, there is something that's called an outbound scan, which is essentially where the carton goes through an RFID tunnel, and all the RFID tags and therefore also all the items that are in this carton are read by the RFID tunnel. So we know exactly which articles are actually going out of the factory. In the warehouse, something that we call an inbound scan is happening. So the carton again goes through a tunnel installation where all the articles that are in this specific carton are read. And if any article is missing, we can do automatic reordering so that the supply chain basically automatically updates itself, and we can make sure that the right articles are always where they actually have to be. In the warehouse, then the whole cartons get opened, repackaged, and all the articles that are required to go to the stores will go to stores. But before they actually leave and are sent to the stores, another outbound scan happens. And again, in the store, we have another inbound scan. So as you can see, all the different steps are monitored, and we can actually calculate efficient and accurate KPI. So this is kind of like the supply chain traceability. We know exactly where and when articles are and should be. But the very nice thing now is that now we have RFID tagged articles in the store. And this allows us to create new services and insights, which particularly build on artificial intelligence. So just to give you an example what RFID actually is and how an RFID stock take actually works in practice, I'll show you a quick video of one of our colleagues doing a stock take. On the right side of this video, you see the visualization of our app, where my count basically resembles the number of articles that have already been accounted for, so that were already read. The accuracy is basically the percentage of the articles that should have been that have been read, and the differences is the overall number of articles that are still missing in this stock take. So, and what we can see here is that with RFID, one of the biggest benefits is you don't need direct line of sight to actually do this stock take. So you don't have to go to every single barcode, scan the barcode, and basically manually count all the articles. It's just enough to point the mobile reader into the direction of the articles. The RFID tags will be picked up, and you can do stock takes of several thousands of items in a few minutes. So this is how the RFID stock take looks in practice. And now one of the questions, or the biggest question is, we know how RFID works, we know how the supply chain works, how can we actually combine artificial intelligence with RFID? And to that end, we have developed several different machine learning methods, and we use big data for operational process optimization. And one of the biggest operational process that RFID helps to improve is actually the RFID-based stock take and the replenishment that follows after the stock take. So our customers conduct daily or weekly stock takes depending on their actual use case. And when they do such a stock take, they send lots and lots of data to our backend, where we use data mining and machine learning to process the obtained data. So customers do this stock take. After they're done with the stock take, we use data mining, machine learning, and several other things to calculate these replenishments. Replenishments are essentially listings of articles that are missing on the sales floor. If store staff knows which articles are not represented on the sales floor, they can grab them in the back room and replenish what's missing on the sales floor. Using that, they will improve the on-floor availability and the stock accuracy as well. So if you're, our customers that are not using RFID-based software solutions usually have a stock accuracy of around 60 to 80%, and an on-flow availability of around 50 to 55%. So on-flow availability also means all the articles that I have in the back room are also represented on the sales floor. Using our software, our customers have a stock accuracy of well above 99% and an on-flow availability of well above 98% on average. So this is actually quite good, but the optimizing these operational processes is tricky, and especially the replenishment process is rather tedious to do, because you can imagine that you might be presented with, let's say, 160, 200 items that need to be replenished. And this is exactly where we are trying to support store staff using our AI-based technology. So, and in particular, we use neural networks for item location. So we and specifically long short-term memory neural networks. And we use big data processing pipelines to iteratively update our models, so that we then know exactly where an item is located in the back room. And using this information, we can calculate AI-driven pick lists. So pick lists are essentially the replenishment advices that are generated. And we generate them based on optimal path approximations, where we leverage exactly the item locations that we calculated before using neural networks. And as I said before, one of the problems that our customers have is, so they usually do a stock take, let's say 30 minutes before the store opens, and then they get presented a list of 200 to 300 items that need to be replenished. And as you can imagine, 30 minutes might not suffice. So we also included different grouping options to our pick lists. And those grouping options concentrate on different features where also store managers can choose and select which feature they think is the most important one. So if store staff can only replenish, let's say, 100 of the 200 items that are in these pick lists, then they can concentrate on, for example, the ones that generate the highest revenue, or the ones that are fastest to pick in terms of minimizing the distance that store staff has to run around while picking up the items to replenish. And of course, combinations of these grouping options are also an option. So to give you an example of how this can look like, this is a visualization of one of the back rooms of one of our customers. So it's very high level. Essentially, the blue dots resemble shelves and racks where items had to be picked up for the replenishment process. And the orange lines or arrows represent the walking paths of store staff when they were doing this replenishment. And as you can see, there is no apparent pattern, or it looks very random, actually. And we applied, so for this specific example, we applied the distance-based grouping option, and we can actually create these AI-driven pick lists that concentrate on actually picking articles that are very close to each other. So there you see a system, and it's not as random as the previous example. And this should also minimize time needed for the whole replenishment process. All right, so now that we know how to put stuff on the sales floor, we are also interested in what is it that we should put on the sales floor, and also in which quantity. And to that end, we also looked into AI-driven planograms, as well as money mapping or visual merchandising to some extent for optimized product availability. So what's very important to understand is when we talk about AI-driven planograms, we are talking about the quantity of in what quantity an article should be represented on the sales floor. And here, I'll give you an example. So if we have this specific blue sweatshirt, then we would create a planogram exactly for this blue sweatshirt. And the planogram would define essentially how often this blue sweatshirt should be represented on the sales floor in what size. So here, this blue sweatshirt would be represented once in size extra small, twice in size small, 3 times in size medium, and so on the sales floor. And for the, I'm a data scientist, so I really like to have just numbers and tables. So this is essentially what we are working with. We just have it in tabular form. One column represents the size, and the other column represents how often should this specific size of this specific article be represented on the sales floor. And as you can imagine, this is super tricky to actually do manually, because you would have to do it for every single article. And usually, I think the average store has something around 5,000 different articles on stock. So that's a lot of planograms that would have to be manually created and curated, because over time demand might change. So these planograms also have to be updated. All right, so to create these planograms, we use ensemble models, which leverage several different heuristics which are based on customer demand, as well as different product master data that that we use to create these heuristics. And we also allow for rule-based constraints. To give an example, so rule-based constraints could be, for example, I never want to have more than 10 items of this specific blue sweatshirt on the sales floor. Or another example could be, even though I know that I will never sell the size extra small and I only have one of them on the sales floor, I don't want to remove that size from the sales floor. Additionally, we use neural networks for customer demand predictions, which is predicting sales. And we are trying to, or we are using this data in combination to adapt planograms for individual retail stores. And I think this is very important to understand. So we are creating these planograms for every single article and for each retail store individually. Because one can imagine that, for example, stores in the East Coast of the US serve a different demographic than stores on the West Coast, for example. All right, and having these planograms and calculating these planograms allows us to optimize article availability, meaning that we actively try to avoid out of stock situations on sales floor, meaning that certain sizes are not available on the sales floor of any given article. And this kind of like implies that we try to minimize lost sales because certain sizes were not represented on the sales floor. And it will also improve customer satisfaction because customers will always find their size available on the sales floor. All right, so now that we have the planograms covered, another topic that we actually process at Detego is money mapping. So if you're not familiar with money mapping, I'll give you an example of what it actually is. So given a random blueprint of a store, and in this case of a sales floor, for money mapping, we would assign reference tags to fixtures in that store, meaning that we would essentially go into these stores and put RFID tags on shelves, on tables, on racks, and map those tags to the given fixtures in these stores. Once we've done that, store staff continues to go about their daily stock take routine, so nothing changes for the store staff. And in the back end, we will be able to map articles to fixtures, meaning that we will know exactly which articles are actually located on what fixture. And if these articles are then sold afterwards, we can actually map hot and cold zones to the stores. So for example, if we are close to the entrance of the store, then there is a table, and that's a red zone, meaning that lots of sales happen from this specific table. Also, we can combine the AI-driven planograms with money mapping, meaning that if we know that we are putting articles into a hot sales zone, we can adjust planograms and put out more articles or more items of the different sizes to account for this hot sales zone. Again, we use LSTM neural networks for item localization, and we will also, so using money mapping, we also gain actionable insights into the customer experience, because we will know more or less where in the store customers actually buy articles from. And to some extent, this might also serve as an approximation to where articles actually are in the store and browse articles in the store. We will also gain actionable insights into visual merchandising, meaning that we will we can actually come up with different visual merchandising strategies. For example, putting up some flashy banners in an area of the store which sees not a lot of sales, and actually quantitatively evaluate if the visual merchandising strategy pays off. On a global scale, so this is just for single stores. On a global scale, we can actually do a lot of additional things. So for example, we can compare product placement and visual merchandising. If we have stores with a similar layout and we see some combinations of articles that sell very well in one store or in several stores, but in others, this combination doesn't sell very well, we can use this money mapping to see how far away these articles are actually placed in the store where this cross-selling does not happen. And then we can create actionable insights for this specific store and ask them to kind of like reorder the articles and put the ones that are actually very well cross-selling closer together. The same goes for visual merchandising. If we know that certain visual merchandising strategies pay off in some stores and not in others, we can then again infer and see what's the difference. Why is it working in some stores and not in others? Yeah, we can identify cross-sellers, and another thing that's very important is we can conduct A/B tests. So essentially, we can run several different strategies, for example, for visual merchandising, and evaluate multiple different strategies at the same time to see how they impact sales and how they impact customer satisfaction and so on. And as I said before, the obtained insights are again additional input for AI-driven planograms. All right, so now that we know what we should put on the sales floor, how can we actually leverage AI and big data so that we have the right products at the right place at the right time? Meaning we always want to have enough articles in the backroom so that we can actually replenish them if we have to. To that end, we'll look into inventory availability optimization. As I said in the first example of the supply chain, all the different reads and scan events are stored in our back end, so we know exactly when an article kind of like arrived in one location, left in the other location. We know exactly when an article was put on the sales floor and how long it took the article when it was on the sales floor to be sold and so on. So all of these different KPIs and dwell times are stored in our back end, and we can use them to actually predict customer demand for timely reordering. So we know the supply chain dwell times. We can infer and predict the customer demand, and we also know the store stock. So we can create probabilistic models for reordering recommendations, meaning that if, for example, I only have one item of size M of a given article in the backroom anymore, and I know that I will likely sell out of this specific article in this specific size within the next 2 days, and reordering takes 1.5 days to arrive in the store, we create these reordering recommendations for our customers, telling them, you know what, now would actually be a good time to think about reordering this item, because otherwise you will run into this out of stock on sales floor situation where you will not be able to refill the article or replenish the article because you don't have it in your backroom. And it will not arrive in time if you, or likely not arrive in time if you don't reorder it right now. Similarly, we do store-to-store shipment recommendations, which essentially look into the or include the sales of the different stores as well. Meaning that if we know that there are certain stores that have articles that they sell in a very high quantity, and there are other stores where this is actually a little bit problematic, so they are not able to sell as much as the other stores, and they will likely not be able to sell all of their stock. We can create these recommendations telling them to, maybe you want to shift your inventory across the stores. Maybe you want to send most of the articles that you have, or most of this specific article, to a different store, because they will be able to sell it before we have to sell all of the articles off in the end of season sale, for example. And again, we can leverage cross-selling information for planogram and visual merchandising updates. So again, because this is, so we do the planograms, and we would also do visual merchandising and money mapping on individual store level. So that's important. All right. Now, one of the biggest problems that we had at Detego when we were creating most of these AI features was that in the fashion industry, particularly, the stock or inventory of our customers changes rather frequently, which makes it super hard to train AI models and come up with algorithms that actually work if you don't have enough or a lot of data for the different articles. So essentially, the problem we have is we have millions of records per store because we have stock take data and a lot of product master data and so on. But the data is only useful for a very limited period of time. So, for example, we have seasonal products which are only available during, I don't know, summer. There are very few articles that are available all year round, which is kind of like the blue circle that you see in the visualization. There are more articles that are available only through specific months or through specific seasons, but the majority of articles in the fashion industry are actually only available for a few months, so for a very limited period of time. And just when you have collected enough data to actually properly train your machine learning models, the article will go basically out of season and is phased out, and all you've learned essentially cannot be used anymore because you cannot recommend the article anymore, or there is no information to be gained from that data. And the problem is, once the old articles are phased out, new articles are introduced, and you have no information about these new articles to work with. So we actually call this problem the transient big data problem. So it's a combination of cold start and transient big data. And we use neural networks to embed product master data, which consists of images, text, as well as sales information, so that we can actually map these phased out products to newly introduced products. So to put it simply, essentially, we look if we have, so if a new product is introduced, we look if we have a similar product or data about a similar product from the past that closely resembles and matches this newly introduced product. So this process is not perfect, but it allows us to reuse existing data for these newly introduced products, and the recommendations and the machine learning models for all the different features that I talked about greatly improve using this approach. So this actually works quite well. All right, so now I'm coming to the basically the last point of this webinar, which is RFID and AI for new services and insights. And in particular, I'm going to talk a little bit about the smart fitting rooms, which bridge the gap between online and offline e-commerce or commerce, essentially. So as I said before, the smart fitting rooms. So this is how our own smart fitting room looks like. Essentially what it does is customers go or browse articles in the store. They take the articles with them in the fitting room. In the fitting room, we have an RFID antenna, which picks up on the articles that are brought into the fitting room. So we can display additional information about the articles. You can also see that in this picture, the customer who is currently looking at this red skirt is actually ordering a new size. So maybe if you've tried on size small and you find, okay, it's still not fitting very well, I want to try on size extra small, you can use the smart fitting room to actually more or less order the different size of that article to the fitting room. And what's very important here in this picture is that on the very bottom, you see these three articles which say you might like, or you might also like, which are product recommendations similar to those that we know from the online world. Meaning that if, and this is also true for ordering these articles to the fitting room, if customers would interact with these recommendations, they would create these orders for store staff, which and each and every single staff member has their own mobile device where they get notified. Fitting room number 3 wants to have this specific article in a specific size, and then store staff just basically says, okay, I'm on it, and a few minutes later, customers will get the articles brought to the fitting room. And this is also how these product recommendations work. So we use recommendations based on product embeddings mostly, and we also create so-called fitting and shopping baskets, which is also very important to differentiate between. Right now, we only have information about what articles customers actually buy. If you think about an online setting, then Amazon, for example, always knows which articles customers have put into their shopping cart and which were then removed from the shopping cart and so on. With the smart fitting room, we now have something similar because we have these fitting baskets. So we call them fitting baskets, which essentially are all the articles that were brought into the fitting room. And we can actually use these fitting and shopping baskets to create what we call, or what is called session-based product recommendations. So over time, if the articles change that are in the fitting room because, for example, the customer orders a different size or clicks on a recommendation and asks for the recommendation to be brought into the fitting room, then we have this timely information of how the articles actually changed that are in the fitting room, and we can adjust or refine actually the product recommendations that we display to the customer. And as I said before, this also represents a new engagement channel where we have this whole order to fitting room process, and it also allows our customers in the future to do self-checkouts. All right, so this brings me to the end of this presentation, and I'm very, very happy to answer questions.